Hello everyone. So I wanted to go over another example of how you determine m and n from a table of data. So here we have the reaction 2a plus b goes to c plus d. And in the rate law, we're only looking at the reactants. The coefficients don't come into play at all. We need to use the data to find m and n. So here's our table of data. We want to look at only the effect of A first. So to do that, we have to find a place where B doesn't change. The first two lines, the first two experiments, B doesn't change. So we're going to take 0.450 divided by 0.150, 0.450 divided by 0.150 raised to the power m is equal to, and now we do the same thing with the rate for the same two experiments. And notice what I did a little trick here. You don't have to do this. I mean, you could enter it into your calculator, but it makes it easier if I get all the exponents the same. So what did I do? I multiplied 1.10 by 10 and I got 10.1, and then I divided this by 10 and I got 10 to the minus 5. So 10.1 times 10 to the minus 5 is the same thing as 1.10 times 10 to the minus 4. But it makes it much easier to work with. So I take this number and divide it by that number. So that's what I have here. 0.150, I just canceled out the tens to the minus 5, 0.150 divided by 0.3, what did I just do? Oh, no, excuse me. So I take, that was wrong. So I take 2.54 times 10 to the minus 5 and divide it into 10.1 times 10 to the 10.1 times 10 to the minus 5. So over here, did I make a mistake there? No, that's 3.38. Okay, it's over here. Sorry. 10.1 times 10 to the minus 5. 10.1 times 10 to the minus 5 divided by 3.38 times 10 to the minus 5. Whoops. Okay, so that's what we have here. Sorry about that. So here it was 0.450 divided by 0.150, and then over here it's going to be 10.15 times 10 to the minus 5 divided by 3.38. Okay? When we do this division, cancel that, we're going to get 3. So we're going to get 3 to the m equals 3, so m has to equal to 1. Also, what we're going to see, notice that the rate of increase is tripled. You're tripling this and you're tripling that, going from 3.38 to 10.1. So when you triple one and you triple the other, if the rate of increase is the same in both, it means it's first order. But also using our method, we could see it was first order. Now we go over to B. To get the concentration of B, we have to find a place where A doesn't change. So it's the lines 2 and 3. A does not change. So what do? Well, we're going to take 0.150 divided by 0.300. 0.150 divided by 0.300 is equal to, whoops, I hit the wrong button. Hold it. Sorry about that. Okay. Oh, what did I do? There we go. Okay. And then what I do, let's do that again. So I'm going to take 0.150 divided by 0.300. 0.150 divided by 0.300 raised to the power n is equal to, and then the same two lines, I'm going to take 2.54 times 10 to the minus 5 divided by 10.1 times 10 to the minus 5. 2.54 times 10 to the minus 5 over 10.1 times 10 to the minus 5. 10 to the minus 5's cancel. Now, if I take 0.15 divided by 0.300, I get 0.5, or 1/2. If I take 2.54 divided by 10.1, I get 0.25, or 1/4. So 0.5 to raise to a power equals 0.25. Well, n is have to equal to 2. Another way to look at that is if I had 1/2, 1/2 to what power equals 1/4? N equals 2. Okay. And by the way, notice something too is, let me look at it this way. As you're going from, well, never mind on that. Anyway, what I just wanted to tell you. So M is equal to 1. So the concentration of A is 1. We don't show it. And the concentration of B is 2. Put it there. And so that's going to be the right answer. Okay? So again, our method is just to first find two lines where the other one doesn't change and use those. And then set up your ratios according to our method. Okay, so this one was a second order. Yeah. Okay, I hope that helps. And this is Professor Coppola signing off.